And it's a little bit like a probability question. Okay, so it says 2 envelopes contain red cards and blue cards. The first envelope, I'm just going to kind of write this out of the problem here. 12 red, 6 blue. And the second envelope has 8 red and 10 blue. Card is drawn at random from both of the envelopes. How would you calculate the probability that both of them are going to be blue? So what's the probability I get a blue from the first envelope? Probability you grab a blue one out of the first envelope. And you don't have to reduce it. What do you think? 1/3. Be 6 out of 18, which is 1/3. All right, now, what is the probability out of the second one? I draw a blue. It'd be 10 out of 18, which reduces to 5/9. Okay, now, do these events affect each other? Like, does what I draw out of the first one affect what I draw out of the second one? No, these are independent. Okay, so all you have to do here, do you remember, do I add or do I multiply? Multiply, you're going to multiply. Don't need a common denominator or anything like that. We're just going to multiply. So we're just going to do 1/3. And if you didn't reduce the fractions, we should get the same answer. So I'm just going to use my math enter to reduce that for me. Should be 5 out of 27. And let me I just don't remember how this is on the final. I'm going to just write down the decimal too here real quick. This would be about 0.185 to 3 decimal places. So like an 18.5%. I'm pretty sure it's not going to be as a percent. It'll either be as a fraction or a decimal for any of the probability questions. All right, now, properties of logs. I've got 2 properties going on here. This is actually a natural log, which also has the same rules as a regular log. But I just want to write one thing for you real quick. The square root is the same thing as what power? You guys remember? If I do a square root, it's the same as taking that to what power? Not the second. 1/2. 1/2, yes. I do that on my calculator all the time. Like if I have a square root, I just do the 1/2, like I do it to the 0.5 power all the time. If you ever want to use that, it's a little bit shorter than grabbing your square root button. But let me, just to the side here real quick. The square root, they never write the index, right? They do that for cube root, fourth root, whatever. But the square root, it's implied. But if you would think about it in that format to reverse the bottom out, that would be the 1/2 power. Okay, the reason I'm making a deal about this is because I can actually use 2 properties when I break this apart. So I have a product. The product you separate with addition. So it would just be natural log of 6 plus natural log x to the 1/2. You can do this in one step if you want. I just want to show you the 2 different properties. So I have a product there, and I separate that or expand that if they ask you to expand that to 2 separate natural logs. They're adding. Multiplication turns into addition. The other thing I could do here is the power property, and I can just bring that 1/2 down in front. So anytime you have a power, you can actually bring it in front of the log or natural log, in this case, with multiplication, and then that's completely expanded as far as you can go with all the properties there. So I use the product rule, which was from the multiplication of the x to the 1/2 and the 6, or the square root of x and 6. The other one was the power rule. All right. For 41, inverse, all we're going to do is switch x and y. So I'm going to write x equals 3y squared plus 5. And then I'm just going to get y by itself on one side. So don't take a square root till you get that y squared all by itself. I'm going to subtract 5, but let me actually come over here. I just need to have the y on the left. So I'm going to write 3y squared x minus 5. Okay, now I'm going to divide this by 3. So I'm just going to divide that whole thing by 3, and I'm going to write it in this format because this is the format for how it's written in the multiple choice options. So I would have y squared equals this x minus 5 over 3. Don't simplify that. You can't simplify that. What I would do then is take the square root. So what you need to remember, whenever you introduce the square root into the problem, you got to put that plus and minus symbol. And then you don't need to rationalize or anything like that. The multiple choice options are just written in this format. So it just will have a big fraction under a square root. You don't need to rationalize anything. Okay. Now, I feel like the next problem always like upsets people, but really it's not terrible. You just want to think about this as just two separate problems for a second. So let me just cover up the denominator. We'll just look at the top. I'm trying to add fractions on the top there. So if I add or subtract fractions, we have to have a common denominator. So if I had my two denominators, 2w and 3w, what would maybe be a good common denominator we could use between those two? Yeah. Okay, you've already got a w in each, right? So you don't need to introduce a variable. Just make them so it's 6w. So top and bottom here, we're going to multiply by 3. Top and bottom here, we're going to multiply by 2. Bless you. Don't forget you are multiplying by 1, so it doesn't really change the value of the expression. It just looks different, so we can actually add these together. And don't forget to multiply. I had somebody yesterday that was adding. So 3 times 3 on the top of that first one would be 9 over 6w. And it should be, if you wanted to go reduce it, that would go back to what you had. So that's what we're doing there. And then the other one, we'd have 8 over 6w. And then you literally just add them. So 17 on the top, don't change the denominator when you're adding. They just stay the same with that common denominator. And then I'm just going to treat the bottom as a totally separate problem for a second. What would you use as the common denominator between 4w and 9w? I think we got to use 36. I don't think they have any other common factors. We got to use 36. Okay, so top and bottom here by 9. You don't need another w. You already have a w in each. So don't introduce another variable that you don't need. And then the second one, 4 over 4. So I'm going to have 9 over 36w minus, this time, 20 over 36w. And then you just go ahead and subtract once you get the common denominator. So we'd have negative 11 36w. All right, once you got it down to two fractions, if you divide a fraction by another fraction, it's the same as multiplying by the reciprocal. So we're just going to do keep, change, flip. So I'm going to keep the top, which is 17 over 6w, change that division to multiplication, and then you flip over, that gives you the reciprocal, the bottom. So we're going to do 36w, negative 11. Now, wherever you want to do this, you can do it right now if you want. These w's are going to cancel out. And I'm just going to go, let me just go straight across the top, straight across the bottom. You don't need a common denominator here. So I'm just doing 17 times 36 real quick. That's 612. And I don't need a calculator for this. 6 times negative 11 be negative 66. And then I'm just using my calculator. I'm just dividing 612 by 66. Do my math, enter to get myself a lovely fraction. It should be negative 102 over 11. So the w's would cancel out there. I know it doesn't ask you for that, but the only restriction there would be if it asks you that w can't be 0, because the only time we have a denominator potential to be 0, you have w times a number, so in every case there it would just be 0, can't be your w value. All right, what does this say? Macy kept track of how many text messages sent daily for 2 weeks. Within how many standard deviations of the mean do all the data values fall? Okay, so we definitely don't want to do this by hand, right? We want to use the calculator to do it. So I might jot down how to do this real quick. All right, I need to figure out the smallest number and the biggest number, because that's the range I'm going to have to cover for figuring out the data values, how many standard deviations they fall. So let me just see, let's see. Looks like the minimum here, 64. And the biggest number, I got a 172. Okay, so we have to cover all the data values, figure out how many standard deviations. So if you forget how to do this, I might jot this down. I'm just going to hit, I'm going to come over here in this space. I'm going to hit stat, and I'm going to hit enter. And that should just take you to the screen where you have your list. So I'm just going to use list one. I got some data in mind, so I'm just going to arrow up to the top, hit clear, hit enter. Don't delete, use the clear button, hit enter. It should wipe out the whole column. And then you don't have to type these in a particular order, but I'm just going to type these data values. So I've got 100, 125, and then just go down the list. Enter in between each. The question on the final doesn't have quite as many data values as I have here. I'm just going to go back and check my list real quick and make sure I didn't type anything wrong or type 2 on the same line or something like that. And then we should be good. So after you want your data here in list 1. Okay, after you do that, we're going to do two things. You're going to hit stat again. You're going to arrow across when you get in that menu to the menu that says calc. And then you're just going to hit enter. And that should say the one, it says VAR stats for one variable statistics. But that's where we're going to get like mean, median, if we needed a box and whisker plot, all that stuff. So stat calc, and then just keep hitting enter until it shows up. Okay, now you need two things here for the question. We need the mean, which is not the greatest number in the world. So I'm going to put 106, I don't know, let's put 106.4. And you need your standard deviation from here. So remember, the standard deviation is going to be the little OX, which for this question, I'm just going to do it to the nearest tenth. So I'm going to do 25.6. Okay, now to figure out how many standard deviations all these, sorry I'm throwing things, all these values are from the mean, you're going to add that number, subtract that number from the mean. That'll give you within one standard deviation. Okay, so I'm just going to keep adding it until I get up to 172, or what would cover 172, so I can figure it out. So I'm going to do 106.4 just plus 25.6, which is actually a nice number, 132. And then I'm just going to do it again, plus 25.6, 157.6, and I would have to do it again, so 183.2. So on that end, I'm going to have to go out at least 3. Let's see how far we have to go out on the lower end. So on the lower end, I'm going to go back to the mean, the 106.4 minus 25.6. This is 80.8. And I need to go down to 64, so minus 25.6 again. Then I'm at 55.2. So to cover the minimum, I only need to go out 2 standard deviations. But to get up to that 172, I had to go out 3 on this side. So it's going to be 3 standard deviations to cover all the values in that data set. I had to go out 1 more to cover that 172. Does anybody have a question? Okay, now I'm going to do 2 things with this next one. It's really small at the bottom of the page here. You have a product to a power. So everybody inside here needs these exponents. So it'd be 125 to the negative 2/3. And then for the x, when you do a power to a power, you're going to multiply the exponents. So we're going to have negative 6 times negative 2/3. If I multiply that there, that's going to give you positive 12 over 3, which is actually going to be positive 4. Okay, I'm going to do one quick thing. This is x to the 4th over. I'm going to move and lose that negative exponent, 125 to the 2/3. Now, you guys are going to be able to use your calculator on the entire thing. So if you want to do this by hand, that bottom out, that would be cube root of 125 squared. Or, and it will be a nice number, if you want to actually just do that on your calculator, I'm going to just clear this real quick. Do 125, use your little caret key to the 2/3 power. You can do it that way too. If you did it by hand, I would do the root first. So cube root of 125 is 5. Then I would square that, which is 25, and you see that's exactly what I got on my calculator as well. So when I answer the question for the multiple choice, it's going to be written like x to the 4th over 25. All simplified there. Does anybody have a question? All right, now we'll solve a radical equation. This is earlier in the semester. So, first thing you want to do, get the radical alone. So I'm going to add a to the other side here. 7a minus 54 equals a minus 6. Okay, what do I do from there? And remember? Like, how do I cancel out the square root? Yeah, worse than square. Okay, now, don't distribute this exponent on this side here. You got a FOIL, right? So I'm going to have 7a minus 54. This would be a minus 6 times a minus 6. If you're squaring something, do not distribute that exponent because you'll completely mess up the middle term and not get it correct. So I am actually going to, I wrote too big. Let me come up here. All right, so I have 7a minus 54, box or FOIL, whichever one you like better. This should simplify to be a squared minus 12a plus 36. You are going to end up with the quadratic, so just set it equal to 0. What I would tell you to do, though, it will be factorable, so if you want to try and factor it, you can, but try to keep the a squared term positive. And so to do that, I'm going to subtract 7a, and I'm going to add 54. So I'm going to get 0 equals a squared, let's see, minus 19a, and then plus 90. Yikes. Okay, can we think of two numbers? When we multiply them, we get 90, but when we add them, we get negative 19. Yes, good deal. Negative 10, negative 9. Now, my actual answers are, because they're multiplied together, give me 0. So either 1, 0, or the other is to make that true. It's what would plug in for a to set that little parenthesis equal to 0. Okay, now, you cannot, just to check, it says check for extraneous solutions in the directions, just real quick. Here's what where I would tell you to check that. Once you get your square root by itself, which was kind of this step right here, before I pretend I don't have that squared for a second. For the extraneous solution part, what I want you to remember is the square root cannot be equal to a negative number. That's the potential for the extraneous solution here. So square root cannot be equal to a negative number. When you square both sides, that's the potential to introduce an extraneous solution because you could cancel out a negative doing that. Now, you just have to check real quick. So I have a minus 6. If I do 10 minus 6, does that become negative? If I do 9 minus 6, is that negative? Then you're golden. Both of those answers work. Just make sure if you plug it back in where you have your square root by itself, make sure when you plug it in that that expression does not end up being negative. All right. Ooh, rationals. Okay. Sam can mow his lawn in 30 minutes. His younger brother can mow the lawn in 45 minutes. How long will it take them to mow the lawn together? So we're going to do two little fractions for rates here. I'm just going to let the 1 represent mowing the lawn. They don't give us any square footage or anything we don't need it though. All right, so Sam, his rate would be that he can mow one lawn in 30 minutes. His younger brother can mow that same one lawn in 45 minutes. That would be his rate. Now it says if they work together, so we're going to add them together, how long would it take them to mow that same one lawn? So what would the work rate be? That is where we're going to put the variable because we're going to figure out the time there. So it's basically the distance divided by the time to get your rate. What would be a good common denominator between 30 and 45? 90. Okay. And then we need an x for here. All right, so I'm going to put an x in both of these. To get 90, we're going to need to multiply this one by 3, this one by 2, and then this one, you have the x, but we'll need 90. If you can make all those lovely denominators match, this is a rational equation. So we can go cross that denominator on out, just operate on the numerator. So I would just have 3x plus 2x equals 90. Once you set that up, that's super quick to solve. 5x equals 90. So x, excuse me, is going to be 40. So it would take them 40 minutes if they were working together. Anybody have a question? Now, log, oh, did I mess something up? Oh, I thought you were telling me this. Okay, now, I want to remind you of one thing before we start this question. For your extraneous solution, you can't take the log, bless you, of 0 or a negative. Undefined. Cannot take the log, that's not 40, is it? That's what you guys were, that's why you guys, I'm like 3 people just looked at me. Miss Grody cannot divide. I don't know why I subtracted 4 in my head. 18 minutes, I'm sorry. Okay. I don't know where the 40 came from. It's early, I guess. Anywho, on this next one, cannot take the log of 0. Like if you actually, if I show you, if I put log 0, it'll give you an error message on the calculator. If you do a log of a negative number, like let's say I put in -7 or something like that, that's also not something that's defined. So just keep that in mind. These have a potential for an extraneous solution if we were to plug in whatever we get as our answer. If it makes either one of these little sets of parentheses 0, or if it makes them a negative number, then it could be an extra answer. Just want to remind you before we start. Now, put these guys together. I'm going to squish these together with the log properties. Adding turns into multiplication. So I'm going to have x minus 2 times x plus 1. And to get rid of the log, we're just going to convert this to an exponential real quick. So this 2 goes over to the other side. It's going to push that other 2 up in the air. Get x minus 2, x plus 1 equals 2 squared. Now, on this side, I would just do, I'm just going to quick FOIL this. Let's see, we get plus x minus 2x, so it would be minus x, and then -2 times 1 is -2. On the other side, we'll just square the 2, that's equal to 4. Subtract the 4 to set this equal to 0. So we've got x squared minus x minus 6 equals 0. Can you think of 2 numbers, if you multiply them, you would get -6, the same 2 numbers, you'd add them and get -1? Do what? Yes, -3, +2. So my 2 answers are 3 and -2. Now, we just have to check if either one of these parentheses would be negative. If one of them is, it's automatically out, or if both, automatically out. But if it makes anything 0 or negative here. So if I plug in 3, this is positive, this is positive. If I plug in -2, this is negative and this is negative, both of them. So the -2 is not going to be a solution there because it makes us take the log of a negative number. So just the 3 would be your answer. Okay. Exponential model for the graph. This is decay, right? So exponential, and this is typed in the question for this actual problem. It gives you that general exponential y equals ab to the x. What you got to grab here is 2 points. And what I would tell you for sure, if you can get a point where the x value is 0, if you can get the y-intercept, use that point, and then any other point you want on this graph. I'm going to go ahead and grab that one, and I'll just grab this one too. So I have 0, 27, and it looks like the y-axis goes by 3s here. So we have the point 19. Okay, you need 2 points because you need to find 2 variables, a and b. The reason I want you to try to pick, if you have a 0, you can automatically get the a value from that point. So if I just take this and plug that into the general form, plug the y-coordinate in for y and the x-coordinate in for x. If you get that x value to be 0, what would always happen there, b to the 0 power is just 1. Anything to the 0 power is 1, so that 27 is automatically your a value. Now, I still need to find the b value, which is why I need the second point. So here's the second point. I'm going to do the same thing, but just plug in those coordinates for x and y, and then we can plug in 27 for a. So I would have 9 equals, I know a is 27 times b to the first. B to the first power is just b. So I have 9 equals 27b. Just divide by 27. then my b value, and it's exponential decay, so it should be a fraction of some kind or a decimal, because my b value, if it has to be between 0 and 1 to create that shape of the graph. And then your actual answer, you got to plug those guys in. So y equals a, which is 27, times b, which is 1/3 to the x. And don't multiply the 27 and 1/3. They should say it's two separate pieces. Does anybody have a question? Okay, we're going to try and subtract these two, and then we're going to do one more question. All right, first thing I'm going to do, I'm going to factor this just real quick. Multiply to get -14, add to get 5. Let me see. I'm going to do +7 and -2. Yes. Okay. What would you do for the bottom? I've got multiply to get -6, add to get +1. 3 and -2. Okay, now I want to make a point about this. In that first fraction, like just ignore this for a second. In that first fraction, 2 of these match up. Completely legal to just wipe that out right now. Just wipe that out right now. They're in the same fraction. Now, I really have x plus 7 over x plus 3 minus 10 over x plus 3 as my problem then. Common denominator already exists in that situation, so you do not need to create one. All you have to do is just combine like terms across the top. So x plus 7 minus 10, all you're going to do is 7 minus 10 on the top. And so we're going to get x minus 3. Don't cancel anything out because we have adding and subtracting there. This is just going to be your answer. Nothing else cancels out. Has to be a product to cancel things out like it was in this first step. That's a product of two factors, so then I can cross it out. If you have adding and subtracting, you can't cross anything else out. All right. Now, we're actually just going to do the 5-number summary here for this set. So this is similar to that question we were working on with standard deviation. I'm going to hit stat, enter, and we're going to type these values in list 1. So maybe if I can get my calculator to turn on. Stat, edit, just arrow up to the top, hit clear, hit enter, and just start typing. Okay, and I'm just going to go back and check because there was a lot of values. Make sure I didn't mistype anything real quick. Okay, once you got it typed in, you're just going to hit stat, arrow over to calc, and just keep hitting enter until it shows up because the information will all be there on that first thing. So stat, calc, just keep hitting enter until it shows up. And then I'm going to write down everything they ask us for here. So let's see, the mean, x bar, that's that very first thing. I'm just going to round it to the nearest tenth. So I'm going to say that's about 70.6. The median is in the calculator screen. That's the second quartile, but it's also called Q2, but you're going to see it as MED in here, which is going to be 71. All right, mode, I'm going to hold off for a second. Q1 is 69, Q3, you guys can see these on the screen, is 74. Now, interquartile range, I'm going to hold off on for 1 second because that's not displayed either. And standard deviation is the little OX, which I'm just going to, let me just do the nearest tenth. It's about 4.3. And the range, not on the, those 3 that I circled are not on the screen. All the other ones are on the screen. So range is just your biggest number minus the smallest number. So for the range, we're just going to do 77 minus 62, which is 15. The interquartile range is Q3 minus Q1, which is going to give you, excuse me, 74 minus 69, which is just going to be 5. And then the mode, no formula for that. You're just going to see if any of the data values are repeated. So if I go back up here, they're all different except for there's 2 70s. So if there's 2 70s, Mode is most often, so there's gonna be a mode for this that's 70.